The countdown has started. The unusual celestial event is approaching and we are unprepared. What do you do when the cataclysmic god of destruction from the cosmos is directly approaching us? According to a NASA study, our planet's defenses against extraterrestrial objects are still insufficient. In an emergency, we can hardly reach safety and avert the disaster. It is likely not us directly that is sending us this chunk. Rather, it is the result of quite normal and even scientifically understandable events in the universe that cause asteroids to strike us. This asteroid has a significant name, Aus. Aus was or is the Egyptian god of destruction and chaos, and it returned thousands of years after the fall of Egyptian dynasties and religion. The Apus itself is just drawn to the light by a magical magnetism. It has no malice in its heart. There are two noteworthy features of this asteroid. It has unusual physical characteristics and is the most dangerous of the modern era. Though, its size enables scientists to observe it with various telescopes and radar systems. Precise analyses are still challenging. The Apus is a relatively large near object with an estimated diameter of between 270 and 340 m. Should an impact occur, it could potentially have a significant impact. Asteroids only sporadically reflect the light of the sun or the dispersed light of planets. They don't emit any light themselves. Aus's shape seems very intriguing. Investigations show that the asteroid has an elongated peanut-like shape, which is typical of bigger asteroids and originates from the merger of two original bodies that were pressed together by gravity's effects because of its irregular peanut-like shape. On the one hand, this is interesting, but if we want to figure out the exact orbit of this body, it can be dangerous because asteroids with this shape tend to behave in a way that scientists call sloshing, which can alter how the asteroid reacts to external forces and affect its long-term stability and trajectory. Will the Yarovsky effect be our undoing? It sounds crazy, but even a slight change in the asteroid's rotational behavior could land. We're in serious peril. The Yarovsky effect is a particularly significant dynamic effect in this context. It happens when a rotating asteroid's surface releases asymmetric heat emissions. During the day, the asteroid absorbs sunlight and warms up, and at night, because of its irregular shape and rotation, it releases the stored heat as infrared radiation. Because of the uneven heat radiation, there is a slight but constant force and change. The effects of this force were dubbed the Yarovsky effect by researchers. With careful measurements and observations, the impact can alter asteroids' orbits like Aus so drastically that they become nearly unpredictable. The second, urgent issue is the precise nature of Apophis' surface. Radar and telescope observations have already given some clues about its composition, and we know that this chunk is probably made of silicate rock. This information is crucial to understanding how the asteroid reacts to external influences like the Yarovsky effect and how it would behave in the event of a potential impact in an emergency. Scientists are working to determine the size and direction of this effect in order to predict the future orbit of Apophis as accurately as possible. In order to push Aus out of its impact orbit, we would need to try. NASA demonstrated that this is feasible with the DART mission, where scientists used a probe to push a small asteroid so far out of its orbit that this EX exercise gave hope for the future. However, we need to understand exactly how Apophis is composed, because pushing the asteroid too far out of its orbit can make it even more dangerous. We also need to know how many attempts we would have in an emergency if we apply too little thrust. Aus will pass within 31,000 kilometers of us in 2029, which is quite close, and we will be able to see it with basic telescopes. It will return in 2036, and an unfavorable constellation may cause the asteroid to collide with something on its next approach, which would mean a terrifying impact in 2036. An account of the danger. You probably were unaware that Aus has been well known since 2004. The terrifying pictures of the tsunami in Asia overshadowed the news that a new asteroid was hurtling our way. Could it be that both stories were published at roughly the same time? The pictures from Asia would be a terrible preview of what would happen to Earth if an asteroid the size of Aus struck us. The asteroid. The asteroid, officially known as AUS, or 99942, was discovered by astronomers at the National Observatory in Arizona. Astronomers were immediately interested in the discovery because preliminary orbital calculations indicated that there was a probable chance that the asteroid would impact Earth in 2029. These early estimates indicated that the asteroid had a probability of roughly 2.7% of hitting our planet. This news caused concern and intense scrutiny in the scientific community, and a few weeks after the discovery, NASA first issued an asteroid warning to governments around the world. By the time the news reached the public media, the Asian disaster was already in full swing. Shortly afterwards, NASA withdrew the warning due to corrections in the orbit calculation, and the general public hardly took any notice of AUS. Only scientists continued their research and constantly calculated the asteroid's orbit in recent years. AUS made the headlines again first. The asteroid Bennu came dangerously close. Then the focus shifted to AUS. Bennu missed and narrowly missed, but it will return, and AUS will also remain dangerously close to the Earth. These two are currently among the greatest threats to our planet. A first highlight occurred in 2013. AUS crossed the Earth's orbit in a short distance, and for researchers, this was a unique opportunity to make progress in orbit. Detailed radar measurements showed nothing good, because AUS will return in 2029, and then again in 2036. This asteroid will orbit the Earth like a pesky fly for the next 100 years, and we must constantly expect an impact. Thanks to the measurements from 2013, we have some high-resolution data that initially reduced the uncertainties and enabled a more precise calculation of its orbit. We can fairly confidently predict that AUS will pass Earth in 2029 at a distance of around 31,000 km. This is closer than any geostationary satellites, but without any direct risk of collision. However, this flyby has a pitfall. When AUS returns in 2036, the Earth's gravity may divert it, putting it on a collision track and giving us 7 years to get ready. The spectacle offered by the asteroid OPUS and the OSIRIS probe is asteroid defense with DART and OSIRIS, the good god of the underworld against the wicked one. OPUS had the opposite idea in mind. OSIRIS was the god who guided the underworld souls into the light and a good rebirth. OSIRIS-REx was first launched in 2016 as a NASA mission to study the asteroid View. It studied Bennu closely and collected samples from its surface, which were returned to Earth in 2023. The probe was then renamed OSIRIS-APEX-X. It is currently approaching Australia, and in a few years, scientists will also hold samples from Australia. These missions are crucial to better understand the physical characteristics and composition of asteroids, because if we want to push them out of their orbit or fend them off with a probe, we must know exactly what materials they are made of and how heavy and dense they are. Only then can we defeat the god of destruction with a DART. NASA's Double Asteroid Redirection Test, or DART for short, was unquestionably successful, but only time will tell. The probe was launched on November 24, 2021, with the goal of using a kinetic collision to divert the small asteroid moon Dimorphos. The test was more than successful, pushing the asteroid even further out of its orbit than anticipated. The mission demonstrated for the first time that a space probe preparing for AUS can alter an asteroid's orbit. What comes next? We must now wait for the nearest. This period may be excruciatingly lengthy, or it may present a favorable chance to think about other asteroid defense strategies and to organize suitable missions. Currently, the world's top nations are working to set up a worldwide planetary defense. The next crucial point is the renewed intensive study of AUS during its flyby in 2029, which will again offer a unique opportunity to observe the asteroid at close range and collect more detailed data that will help us understand its physical properties and future orbit even better. If an apotheosis asteroid comes dangerously close to us, the entire globe would be affected. This project should benefit from the knowledge and financial resources of many countries. We must observe the flyby in 2036, of course, because if a Apophis flies through the so-called gravitational keyhole, its orbit will be drastically changed. Therefore, what matters is how Earth's gravity will affect the POF's orbit. Theoretical models and simulations already indicate that this flyby could alter the asteroid's orbit in such a way that future approaches will be even more dangerous. Although it sounds terrifying, we can only protect ourselves for the time being because many experts are confident that AUS will strike Earth eventually. We might escape it again in 2029 and 2036, but the threat is not over because we never know which asteroids will strike us, so we must ensure that our planetary defenses are already improving. It's as if asteroid defense is still in its infancy, but time is running out. We've launched great probes and deflected a small asteroid, but in an emergency, we need far more experience and safe systems. NASA simulated the worst-case scenario in a major exercise and came up with frightening results. Additionally, NASA revealed significant flaws in global networking and communication. As a result, the most recent study recommends deploying additional space probes to Australia to conduct even more thorough research. Such missions might resemble the OSIRIS-APEX mission, and stationary probes like tiny rovers or orbiters are also intended to permanently accompany the asteroid. After that, we must conduct additional defense tests and eventually create probes that can move asteroids the size of a poppus. Experts are also debating gravitational tugs that can pull asteroids out of their orbits, and they are only thinking about blowing up Australia in dire situations. Get a subscription now to enjoy a ton more future video highlights.